OSPF has this hierarchical structure for areas. We've got the backbone area, that's area 0, and then non-backbone areas which must join up to that backbone. But what if this isn't perfect for us? What if we are challenged with an unusual network, growth of your network that is growth by a merger between two different companies? You might get a situation where Company 2 was using OSPF. It had its own backbone, and Company 1 had its own backbone. You've got a real problem on your hands if you can't deal with that, because Area 0 must be contiguous. Area 0 must be contiguous. That is, in fact, one of the rules. Let's, in fact, make sure we understand that. Area 0 needs to be clumped together. We can't have other pockets of Area 0 in other locations. That's a big deal to us. This is a big deal. So, going back here, you may have a need to repair a discontiguous Area 0, or maybe you have some need. Now, this is actually harder to justify, but maybe you have a desire to daisy chain areas. Now, the way to really make this work is if you had a situation like this where Area 20 is breaking the rule, and Area 20 is breaking the rule. If you don't see it, I want you to see it. You have to have each area border router connecting with at least one interface to Area 0. That's a requirement. Area border routers have to have interfaces directly in Area 0. And without this feature called a virtual link, well then you are out of luck. You would not be able to successfully route to Area 20 here. So OSPF virtual links solve a need. Now, we're not going to tell you that this is a good thing. OSPF virtual links are a band-aid. You do not want to have a long-lasting virtual link in your topology. Why? Because it represents single points of failures, because it's a tunnel that is anchored to very specific routers, and should one of those specific routers fail, then you don't have a backup pathway. And in our routing domains, you don't want single points of failure if you can get around it. OSPF virtual links are an extension of the backbone. The best way to think of a virtual link is it is a tunnel. It behaves as a tunnel. It should be thought as a tunnel. What are tunneling techniques that are similar to this? GRE tunnels. Very basic tunnels give us virtual interfaces. They have connectivity over a transit environment. And what we're doing is we're stretching Area 0. That is, in fact, the way to think of it. We're stretching. Let's say this line that I'm drawing is Area 0. That is the tunnel. We're building that out. And now, if you look closely, this area border router has connectivity through its virtual link to Area 0, because the virtual link is Area 0. In the scenario down below where we have discontiguous Area 0s, which is also a bad thing, we can bridge that gap. We've got Area 0 flowing through that virtual link. And now it's no longer discontiguous. There is a strand between Area Border 1 and Area Border 2. And that strand gives us that conduit to stretch the OSPF Area 0 backbone. That's what we need. Now, you have to be sure that you don't do this over non-traditional areas. You might not know what a stub or NSSA is. We might get there. We will, if you stay with us. But in this discussion, you need to understand you can only do this really across classic non-backbone areas. So we would call this the transit area. Area 1 would be the transit area in the bottom topology. Can you tell me the transit area for the top topology? What would be the transit area for the top topology? Well, the transit area is the area that we are stretching the virtual link over, and it's area 10. I'll tell you, the transit area will never be area 0. Remind yourself that when you're doing OSPF virtual link configuration, because sometimes you can second guess yourself on what the transit area is.